What is the course of the maritime industry? The disruptive trend of green shipping is offering tremendous opportunities for electrification of the maritime drivetrain. On the other hand, this promising trend is leading to an increase of system complexity and more demanding technical requirements. THD levels in weak grids are just one of the various examples to be mentioned. On top, there are general project topics like cost pressure and tough timelines. For OEMs and system integrators, handling this increasing complexity will be a key factor for maintaining their business success. A game changer for doing so is simulation. I wanted to introduce you to the offerings of Siemens Motion Control for simulation and virtual commissioning of complex drive systems, as addition to our comprehensive product portfolio. Let's go on board. The core of any simulation approach is the comprehensive understanding of the real drive system. Generally, we divide this into the control system, the power electronics, and the load, for example, the electromechanical propulsion system. For offline simulation, the real system will be converted into a simplified control and an electrical model. The detail level of this process will be chosen according to project requirements and the simulation target. These models will be implemented in ANSYS Twin Builder, a powerful simulation environment for various use cases. Just to mention a few, this offline simulation approach can be utilized for grid analysis like investigation of THD levels for class approval, proof of system stability, and short-circuit investigation of distributed DC systems based on the geometry of DC bus bars and fuse characteristics. At the beginning, I was talking about challenging project requirements like cost and time pressure. Furthermore, risk minimization is one of the most crucial topics for successful project business. Next, I want to show you how our hardware-in-the-loop simulation and virtual commissioning contribute to cost and time savings as well as risk minimization. Again, the starting point is the real system and the modeling process. This time, a dynamic system model will be implemented on a real-time simulator. This real-time capable model will be the representative of the real system's behavior, the digital twin of the drivetrain. The drive control will not be modeled. Instead, our control unit CU320-2 will be connected to the real-time simulator. This setup is the fundamental for virtual commissioning. It allows us to treat the drive control just like in the real system. With our standard commissioning software, Dynamic Starter or Start Drive, we can perform all relevant steps of commissioning, like configuration and parameterization of the drives, analysis of the system dynamics, or training of commissioning staff. And all of this even before the installation on the vessel has started. In the end, resulting configurations and parameter sets can be quickly implemented to the real system. Plug and play. Thereby, the virtual commissioning is not limited to the drive control. In our simulation laboratory, the whole automation system can be connected to the Hil Simulator. Our customers can integrate the plant automation system based on PLC and IPC, as well as their customer-specific HMI that allows testing of the whole power management system. Let's have a more detailed look at the architecture of the Hil Simulator. In the laboratory, the exact setup of the real control system will be implemented with the original hardware. Besides, the already mentioned customer-specific automation and the drive control unit, as well as additional peripheral components like voltage sensing modules and terminal modules, will be added. The heart of every model drive will be its original Control Interface Module, CIM, with original Intelligent Power Description Data, IPD. All of these components will communicate via the original drive-click protocol for Dynamics drives. Signal conditioning boards will be the interface between the original hardware setup and the real-time simulator. These boards will convert the physical feedback and controls to digital signals for the simulator. For user interaction with the simulation model, an individual graphical user interface will be provided. It allows flexible parameter input for changing electrical characteristics of the model. Furthermore, various measurement tools are available. For detailed investigation, even external instruments like oscilloscopes can be adapted. The advantages of these simulation approaches are obvious. They allow a proof of concept, conceptual failures can be found in the early project phase, and detailed analysis of the digital twin is more effective and can be done in parallel to planning and engineering steps. Especially in case of new developments, our simulation offerings will significantly contribute to risk minimization and the success of your maritime projects. I would like to invite you to come on board and enjoy our simulation and technology expertise.